All right, hello you guys. Okay, so we're gonna go over this review. So first of all, number one, we have x to the negative third, y to the negative fifth, all raised to the fourth power times 3x squared, y squared. So first things first, we gotta make sure that we distribute that power of 4 to both things inside the parentheses. Remember, when you have a power raised to a power, you multiply the exponents. So we're gonna have x to the negative 3 times 4 is negative 12. And then y to the negative 5 times 4 is negative 20 times 3x squared, y squared. Okay, so now here we are multiplying like bases. So the only thing that's not like is this number 3. We always put constants or coefficients out front. All right, and then x to the negative 12th times x to the second is the same as saying x to the negative 12th plus 2. Because you add the exponents when you multiply like bases. So that would be negative 12 plus 2, that's negative 10. And then y to the negative 20th times y squared, negative 20 plus 2 is a negative 18. Okay, we're not done yet though, because anytime we have negative exponents, we never ever leave our answer that way. I gotta drop this like it's hot, and I gotta drop this like it's hot. So my final answer is gonna be 3. That's the only thing left in the numerator, over x to the 10th, y to the 18th. And I can't simplify that any further, so that is the answer. All right, number 2 says, which of the following expressions when evaluated equals an irrational number? Remember, an irrational number is a number that we can't take its square root of evenly. That means it's a number stuck under the radical. That's what makes it irrational. It's a decimal that goes on forever if we were to type it into a calculator. So anytime you have a radical over a radical, you can reduce it as long as they're all inside numbers. Well, since they're all under a radical, I can rewrite this as the square root of 3 over 12. Well, 3 goes into 12, goes into itself once, goes into 12 4 times. So this is the same thing as the square root of 1/4. Well, then I can break it up again. I can write this as the square root of 1 over the square root of 4. What's the square root of 1, guys? It's 1. And what's the square root of 4? It's a 2. So that's a 1/2. That's a rational number. It's not irrational because there's no radical left. So I'm looking for the one that's irrational, so it's not A. All right, let's take a look at letter B. Same type of thing. They're both inside numbers, so I can see 3 goes into 12 4 times. So I can write this as the square root of 4. And what's the square root of 4? It's a 2. So 2 is a rational number, so it's not irrational, which means it's not B. Okay, let's try letter C. Hey, anytime we square a square root, those are inverses of each other. The 12 gets to come out. 12 is a rational number, so it's not C. Okay, letter D. We're multiplying the square root of 3 times the square root of 12. So 3 times 12 is 36. And 36 is a perfect square. The square root of 36 is 6. So 6 is a rational number. It's not irrational. All right, so now let's look at letter E. Letter E is the square root of 3 plus the square root of 12. We can't add these numbers because they have to have the same number under the radical in order to add them. 12 can be broken down. You have to do a factor tree. You want to look for perfect squares. So I'm going to use 4 times 3 instead of 6 times 2 because 6 and 2 are not perfect squares, but 4 is a perfect square. And 4 times 3 is 12. So this is the square root of 3 plus, when I take the square root of 4, the square root of 4 is a 2. So 2 gets to come out, and then you're done with the 4. The 3 is stuck inside. Okay, now that they both have the same number under the radical, I can add them. This is a 1 square root of 3 plus 2 square roots of 3 is 3 square roots of 3. Because I have a square root in my answer, this is going to be an irrational number. So E was the answer. Let's look at number 4. Or sorry, not number 4, number 3. Add and subtract. So same type of thing. We need to do factor trees. 32 is 8 times 4, yes. But I want to look for the biggest perfect square. And if you divide 32 in half, half of 32 is 16. And 16 is a perfect square, and the biggest one in there. 8 is 4 times 2. 4 is a perfect square, and I can't do anything with that square root of 3. There's nothing I can make that lower. So the square root of 16 is a 4. So 4 gets to come out, 2 stuck inside. The square root of 4 is a 2. So 2 gets to come out, the other 2 stuck inside, and then bring down the -5 square root of 3. All right, now I can combine like terms, and I have 4 square roots of 2 plus 2 square roots of 2. Those add up to 6 square roots of 2, and then -5 square root of 3. I can't combine those any further, so that is the answer. Now we're on number 4. It says rationalize the denominator. I'm not allowed to have a radical in the denominator. So to rationalize this, I need to multiply top and bottom by it. So square root of 10, multiply top and bottom. Well, remember, inside numbers with inside numbers, square root of 3 times square root of 10 is square root of 30. And I won't be able to reduce that because 30 is just either 3 times 10 or 15 times 2. There's no hidden perfect square inside of a 30. 10 times 10 is 100. The square root of 100 is 10. I can't reduce that anymore, and I don't have a radical in the denominator anymore, so that one is done. Next page. Number 5, simplify the following expression. So 25, or under the square root of 25, x to the 7th, well, 25 is a perfect square. X to the 7th is not. Let me zoom in a little bit more. X to the 7th is not. But I can find a hidden perfect square in there by finding the next highest even power, which would be a 6. It's always going to be 1 less if you have an odd numbered exponent. And then x to the 1, because when you multiply x to the 6 times x to the 1, you add the exponents, it still represents an x to the 7th. But x to the 6 is now a perfect square. Okay, now we can do this. The square root of 25 is 5, so 5 gets to come out, you're done with the 25. The square root of x to the 6th is x to the 3rd, so then you're done with the x to the 6th, and then that x is stuck inside. So 5x cubed square root of x. And then on to number 6, multiply and simplify. Okay, there's a couple different ways to go. We can multiply all these together, which I am going to, but I'm going to go ahead and do a factor tree on 21 because it's just 7 times 3. And then I am going to have to multiply in another 7. So I have a third number, 7 times 3 times 7. Well, I have a pair of 7s there. So remember, when you have a pair of numbers, that's a perfect square. 7 times 7 is 49. The square root of 49 is 7. So 7 gets to come out. So make sure you cross those 2 out because they're done. 3 is going to be stuck inside. Okay, so that's still going to be inside. So I'm going to rewrite this. We have a 3 inside. And now let's multiply the x's. X cubed times x squared. 3 plus 2 is 5. Y to the 10th times y squared. 10 plus 2 is 12. Z to the 5th times z squared. 5 plus 2 is 7. Okay, so we took care of the number. Now let's take care of the letters. So to take care of the letters, we're going to need to do factor trees on them, just like we did up here. So the next highest even number under a 5 would be an x to the 4th. So x to the 4th, x to the 1. Y to the 12th is already a perfect square, so that's done. Y to the 7th, we can do the next one under a 7 is a 6. So z to the 6, z to the 1. All right, now let's take the square root. So we already have a 7 outside. The square root of x to the 4th is x squared. So x squared comes out, and you're done with the x to the 4th. The square root of y to the 12th is a y to the 6th, and then you're done with that. The square root of z to the 6th is a z to the 3rd, and then you're done with that. And now let's see what's left inside. We have a 3, we have an x, and we have a z. So 3xz, and then that's the answer. 7x squared y to the 6th, z cubed, square root of 3xy. Sorry, I'm having my breakfast at the same time. All right, number 7. Simplify the expression below. So here's how I would do this, especially because I know Bryant, I know he doesn't like to write a lot of work. Not meaning to call you out, Bryant, but Yeah. Here's a quick way to do this. We're adding and then we're subtracting. So the one that we're subtracting, there's going to be a sign change. So I would just rewrite this one. Negative 3n to the 5th minus n cubed minus 10. Okay? Having different colors really does help too. All right, now I'm going to combine like terms, and I want to look for the highest degree. The highest degree is that n to the 5th. So I've got an 8n to the 5th, a 2n to the 5th, and a negative 3n to the 5th. So 8 plus 2 is 10. 10 minus 3 is 7, so that's 7n to the 5th. And then I'll just cross them out when I'm done with them. That way I don't have to worry about them anymore. Now let's look on the next highest degree. The next highest degree is the n cubed. So negative 4n cubed and a negative 1n cubed. They're both negative. So when they're both negative, you add them and keep the negative. So negative 4n cubed minus 1n cubed is negative 5n cubed. And then we're done with those. So I'm going to cross them out so that I know I'm done with those ones. Okay. So then the next highest degree would just be the n's. We've got a 6n and a negative 3n, and then that's it. 6n minus 3n is a positive 3n. And then I'm done with those. Okay, and then the last thing would be I have a 14 and I have a negative 10. 14 minus 10 is a 4. So I know it's very colorful, but that's my answer. 7n to the 5th minus 5n cubed plus 3n plus 4. Number 8, let's multiply 5x plus 2 times x plus 3. And if you got these right during class, you can always fast forward this video to where you need to go. 5x times x is a 5x squared. 5x times 3 is a 15x. 2 times x is a 2x. 2 times 3 is a 6. I've got like terms on the x's here, a 15x and a 2x. I can combine them. So I'm going to rewrite this, and it'll be a 5x squared. 15x plus 2x is 17x, and then plus 6. Number 9, we're given f of x and g of x. We need to find f minus g of x. Write your answer in standard form. So we have to take the f function, 3x squared minus 4x plus 7, and subtract from it the g function. So since I'm subtracting and the g function is 2 terms, we gotta make sure to put that in parentheses, because remember, when we are subtracting, we're not just subtracting one thing, we're subtracting 2 things, so that negative needs to get distributed. So negative x, negative times negative 5 is a positive 5. So now let's combine like terms. 3x squared is the only x squared term, so I'm just going to bring it down. I have a negative 4x and a negative x. They're both negative, so you add them and keep the negative. Negative 4x minus 1x is a negative 5x. And then 7 plus 5 is 12. So 3x squared minus 5x plus 12. All right, and then number 10. Perform the indicated operation. I have h of t and g of t. The first one says find h of t times g of t. So you have to take the h of t function, 5t minus 4, and multiply it by the g of t function, 2t minus 3. And then we're foiling it out. So 5t times 2t is 10t squared. 5t times negative 3 is a negative 15t. Negative 4 times 2t is a negative 8t. Negative 4 times negative 3 is a positive 12. All right, and then we can combine like terms. I only see like terms with the t's there. So we'll have a 10t squared. Negative 15t minus 8t, let's see, that's what, negative 23? Because they're both negative, you add them and keep the negative. Yeah, negative 23, and then plus 12. And then that's the answer. Okay, letter B, g of h of t. So that means we have to take the h of t function, which is 5t minus 4, and we need to plug it in to the g of t function. So we need to plug it in for the t in the g of t function. So when I do that, there's a 2 out front. And then when you plug something in, you always use parentheses. I'm plugging in for t a 5t minus 4 and then minus 3. Okay, we got to distribute that 2. So 2 times 5t is a 10t. 2 times negative 4 is a negative 8. And then there's a minus 3 on the end there. I have like terms with the negative 8 and the negative 3. They're both negative, so add them and keep the negative. So that'll be 10t minus 11. And I can't go any further than that. For part C, it says find g of h of negative 3. Well, we already found g of h of t. That was this. So to find g of h of negative 3, all I have to do is plug in negative 3 into this. Or what you can do is you can plug in negative 3 into the h function, figure out what that is, and then plug it into the g function. That's what you guys had to do in the IXL. Okay. But this one led you to that. So I'm going to go ahead and just plug in a negative 3 in for t. Oops, guys can't see. And let's see, 10 times negative 3 is negative 30. Negative 30 minus 11, since they're both negative, you add them and keep the negative, and that's a negative 41. Number 11 says, what is the difference? So remember, we are subtracting. They're not next to each other, so we're not multiplying these this time. Sorry, I didn't mean to slurp. Anyways, so before I would take care of this, I'm going to distribute that negative. So negative times negative, that'll be a positive 3. Negative times negative, that'll be a positive 13i. So 7 and 3 add up together and make 10. Negative 2i plus 13i is a positive 11i. And there's my complex number, 10 plus 11i. Number 12, what's the product? Product means to multiply. So this time the parentheses are touching, we are going to be multiplying. 4 times negative 1 is negative 4. 4 times 6i is a positive 24i, so plus 24i. Negative 5i times negative 1 is a positive 5i. Negative 5i times 6i is a negative 30i squared. Okay, so we have to remember some things. First of all, I squared equals what? It equals negative 1. Okay, so if I have negative 30 times negative 1, that changes this to a positive 30. Okay, so let's combine like terms. We have a negative 4 and a positive 30. Negative 4 plus 30 is 26. 24i plus 5i is 29i. So plus 29i, and then that is my answer. Number 13. Use the imaginary number I to write each expression as a complex number. Remember, anytime you see an I under the radical, you got to poke an I out. And the square root of 25 is 5, so it'll be 5i. This one has a negative out front of the radical, so that negative is going to be there. And then the negative in the radical, remember, you poke an I out, and the square root of 36 is 6. So 6i, so negative 6i. For this one, there's only a negative under the radical, so that means poke an I out, and the square root of 36 is 6, so 6i. This one, there's a negative out front already. There's an I under the radical, or a negative under the radical, so you got to poke an I out, and the square root of 49 is 7, so negative 7i. And that's number 13. Number 14. Simplify negative 4 minus 4i over negative 8 minus 8i. In your steps, you must show how to use the complex conjugate to rationalize the denominator. So basically, we can't have i's in the denominator, just like you can't have radicals in the denominator. So we have to multiply by its complex conjugate. The complex conjugate of negative 8 minus 8i is negative 8 plus 8i. And I have to multiply that top and bottom to keep it equally balanced. And I'm going to put parentheses because I feel like they're naked without them. All right. Now, there's a pattern for multiplying out the complex conjugates. Anytime you multiply a complex conjugate together, their first number is squared. Negative 8 squared is 64, plus the second number squared. Second number is just an 8. You get to ignore the I, because remember, the middle terms are going to cancel with these, and I squared turns into a negative 1, so that negative 64 is going to turn into a positive 64. Okay? So anytime you multiply complex conjugates, the shortcut, remember, it's a squared plus b squared. The two numbers, the first number squared plus the second number squared. Okay? No matter the sign. All right, in the top, we do have to multiply that out all the way. There's no shortcut. So negative 4 times negative 8 is 32. Negative 4 times 8i is a negative 32i. Negative 4i times negative 8 is a positive 32i. Negative 4i times 8i is a negative 32i squared. But remember what I squared is, it's a negative 1, so negative 1 times negative 32 is going to change this to a positive 32. 32 plus 32 is 64. Negative 32i plus 32i, those cancel. So all I have in the numerator is 64. In the denominator, 64 plus 64 is 128. Well, 64 goes into itself once and into 128 twice, so my final answer is just a 1/2. Number 15. Factor the GCF completely from the polynomial. All right, this is what we just ended with. So let's see. The biggest number that these three numbers have in common is a 3. And the biggest p that they all have in common is a p squared. So when I divide that out, 9p to the 4th divided by 3p squared is 3p squared. Negative 6p cubed divided by 3p squared is a negative 2p. 12p squared divided by 3p squared is a positive 4. And then that's it. Number 16, factor each of the special cases. This looks like a perfect square trinomial, but because it's a minus and then a plus, that means that both factors are negative, or it's going to have a minus sign in the middle. X is in the front, and the square root of 16 is a 4, and when you double negative 4x, you get a negative 8x, so that works. And you could also write this as x minus 4 quantity squared. Letter B, that looks like a difference of two perfect squares. So one's going to have a plus, one's going to have a minus. The square root of x squared is x. The square root of 121 is 11. So x plus 11, x minus 11. And we can't simplify that any further, so that's it. Letter C, this looks like a perfect square trinomial. This one's going to be a little bit harder just because the numbers are bigger. Everything's positive though. The square root of 25x squared is a 5x. The square root of 81 is a 9. So let's just check it. 5x times 9 is 45x, and if I double that, I will get 90x. So the pattern works. And since I have two of the same factor, I can write this as 5x plus 9 quantity squared. Then letter D, 64x squared minus 256. It looks like a difference of two perfect squares, but there is a greatest common factor in there right now, and it's a 64. So I'm going to factor that out first. I'm going to divide it out. 64x squared divided by 64 is x squared. Negative 256 divided by 64 is 4. All right, so now x squared minus 4, that's a difference of two perfect squares. So we have that 64 out front, and that factors down 1 plus 1 minus. The square root of x squared is x. The square root of 4 is a 2. So 64 times x plus 2 times x minus 2. And that's 16. Turn the page. Number 17 says, which of the following expressions represents -2 plus the square root of -16 written as a complex number? Well, we have a negative under the radical, so it means we have to poke an I out. So we have -2 plus, and the square root of 16 is 4, so 4i. So -2 plus 4i, the answer must be B. Well, that was easy. Number 18, here's another complex conjugate problem. We need to get the I out of the denominator. So I need to multiply top and bottom by the complex conjugate of 7 plus 2i. Its complex conjugate is 7 minus 2i. You only ever change the sign in the middle. Okay, and remember the pattern. With the denominator, it's just the first number squared plus the second number squared. Well, 7 squared is 49, 2 squared is 4, so 49 plus 4. And then multiplying this out, 10 times 7 is 70, big numbers. 10 times -2i is a -20i. 6i times 7 is a positive 42i. 6i times -2 is a -12i squared. Okay, well remember I squared is -1, so -12 times -1 makes it a positive 12. 70 plus 12 is 82. -20i plus 42i is 22i. And 49 plus 4 in the denominator there is 53. I can't reduce this because 53 is a prime number, so that is my answer. 82 plus 22i over 53, which means it's got to be C. And then the last one, -2i to the 22nd. The big idea with this, guys, is to remember that I squared equals -1. That's the big idea. So let's rewrite this, -2, and instead of I to the 22nd, let's write it as I squared to the, let's see, to make this a 22, I need it to the 11th power, because 2 times 11 is 22. All right, and then plug in the -1. -1 to the 11th power, well, 11's an odd number, so we have an odd number of -1s, and that means that when I raise -1 to the 11th power, it's just going to be -1. And -2 times -1 is positive 2. So the answer is D. And then that's it. Have a good one, you guys.